All right, this related rates question says, what is the radius of a sphere at the moment that the rates of increase of its radius and surface area are numerically equivalent? Okay, so what do we know here? Well, first of all, we know we're talking about a sphere. Here's our radius here. And we are talking about we're asking what the radius is at the moment when the rates of increase of its radius and its surface area are numerically equivalent here. So let's think about this. I'll zoom in a little bit. What this is saying here is that at some moment, dr by dt is going to equal dA by dt. Okay, that's the specific instant that we're interested in. We know that the area of a sphere is going to be 4 pi r squared. Okay, and what we want out of this problem is we want to know what r is, what the actual radius is. Okay, so this appears to be the equation that we're looking for right here. So let's just jump into it. So area is equal to 4 pi r squared. And let's just jump in and take the derivative. So the derivative of a with respect to time will be 4 pi. This will be 2r dr by dt. Okay, because we're anticipating, that we have to take the derivative implicitly with respect to time. Okay, and time doesn't show up in there, but we're assuming that a and r are both functions of time here. Now, we're going to figure out what r is. In this case here, we know that these two expressions here are numerically equivalent, meaning I can divide both sides, for example, by the derivative of r. Actually, it might even make more sense, just so that everybody follows along here, if maybe what I'll do is I'll perform a substitution here. And I will let dA by dt simply be dr by dt. This might make more sense here. This ends up being 8 pi r dr by dt. I can do this because at the moment that I'm interested in, those two are numerically equivalent, which means I can now divide both sides by dr by dt, and I'll get 1 over 8 pi is equal to r. Whoops. And so there it is. Now, just so that we have an idea of how big that value is, I'm going to figure out the decimal equivalent, and this is going to be 0.04 approximately units here. Now, notice that at no point here did we ever actually identify what the units are. And that's because we don't really need to know at this point. However, whatever units we were looking at in terms of this for measuring the radius here, it's going to have the numeric value. It doesn't matter, essentially it doesn't matter what units we are measuring with. Numerically, the value of that is going to be 1 over 8 pi or 0.04 approximately units.